Hello, everyone. Welcome to the binary episode of the podcast. I'm Spectre. With me is Z. Today we have a fairly scary XNU mitigation posted by Apple Security Blog, a bug in SQLite, a NetBSD bug, and some other stuff scattered in there. First, though, Z will get into the spot the vuln solution for the week. So, Z, I'll let you get into that.
And this week's Spot the Vuln was another kind of high level issue. What we've got here is I wrote this in Go. I've seen this code more in like Java elsewhere too. It can happen pretty much any language. It kind of actually depends a little bit on infrastructure too. But what we've got here is this imaginary task handler, handle new task. Request comes in, parses out some arguments from it. I'm imagining like a JSON setup, whatever. It checks the callback URL, effectively just making sure that whatever host name you give it, it resolves to a IP address that they allow. There's a is allowed IP address that just iterates through all of the possible IPs. It gets back to that host name, checks that they're all allowed. If they're not, then it just rejects this whole thing, runs a task, and then at the end actually makes the callback with whatever content. The issue there being that it does this host check, it checks the IP really early on before it actually runs the task, and then at the end, if that DNS entry has expired, if the time to live is fairly short, or if it's shorter than the actual time the task took, we don't really have any indication here that the task will necessarily be very long, but since there's a callback, you can kind of assume it'll have somewhat of a delay. Because of that, it could end up doing a second lookup when it actually makes the post, where a attacker could basically set up their domain to give a new IP address, one that isn't whitelisted at that segment. So a DNS rebinding issue. I kind of gave it the name right code, wrong place, because ideally you'd be doing that host lookup right before you make that call so it can't expire, and possibly even passing in the IP and just setting the host specifically, or explicitly, sorry, as you make that request. Although having, depending on your infrastructure, if you had like a caching resolver in there, it might hold it longer than the task takes. There are other places you could kind of prevent this sort of attack, but yeah, I thought it was a fun one.
Yeah, it's an issue that, like I was saying to you yesterday before we started the show. It's not something I would immediately have in mind when looking at it. So, yeah, it's a bit of a different issue than some of the ones we've had in the past. So, I thought it was cool in that respect.
A little bit different. Definitely out there. Definitely some that is found. We've covered it a couple times on the podcast where it's been found in the wild, usually on the bounty side of things.
Yeah. All right. So, I kind of mentioned yesterday that I'd be shouting out the Hexacon talks today, so we'll get into that here really quick. For those that don't know, Hexacon was a newer conference. This was actually their first year. It was hosted in Paris, and yeah, they have a more offensive security driven goal in mind with the talks, and it's a little bit more binary focused, which is why we covered it today instead of yesterday. Pretty much all the talks are going to be like attacking browser or kernel stuff or other binary type targets. A lot of like really interesting talks there and a lot of really good speakers. So it's definitely worth checking out. It is a conference I'd like to attend in future years. It seems it went pretty well this year. So yeah, they have like the talks, they have the trainings and everything. I wanted to give it a shout out. I actually listened to one of the talks yesterday, which was QWERTY's talk, and that ties into our first topic actually. So I'll be referencing some stuff from that. We would like to do some coverage streams on these talks as well. We're not 100% sure if we'll be able to. We just need to do some checking. It might be something similar to what we had to do for Offensive Con, where we can only do it on YouTube, but we'll have to see. And once again, just like the DEF CON talks, we'll let you guys know if and when we'll be doing those through Discord and Twitter. But yeah, like I said, some really cool talks here. Some other ones I will be checking out for sure. And I think there's some cutting edge, good knowledge to have you can get from these talks. So
Yeah, it definitely looks like a good set of talks. I haven't had the chance to actually go through any of them, so I can't comment. But given the background, given the lineup here of people presenting at it, it seems like a solid con and solid videos.
yeah. All right, so let's get into our first topic here, which is by Apple's security research blog, which is not a sentence I ever thought I would say on this show. But here we are. Apple started a research blog. and they've kickstarted it with a post about chaotic type, which is something that was talked about by Cordy in his Hexacon talk that I mentioned. And chaotic type is a new mitigation that's came to XNU and iOS. I think it was introduced in iOS 15. And it essentially boils down to stronger heap sequestering at an allocator level. So to give a bit of background, being able to manipulate heap memory and get certain types of objects to occupy certain memory locations has always been a pretty foundational part of memory corruption. For use after free, obviously it's pretty important that you're able to replace some kind of object in memory to do something useful, whether that's hijacking a pointer to get read write or code execution or whatever else. But even outside UAF, you may want to get a target object adjacent to some object you have control over as an attacker to be able to overflow or do some kind of adjacent corruption that way. The goal of this mitigation is to essentially kill strategies that rely on that. If not completely kill them, to at least make them less reliable and less reusable, to try to kill off exploit techniques. So top of the blog post talks a bit about memory corruption and the XNU allocator, which for all intents and purposes is basically a slab allocator. So you have slabs or chunks of memory, which are of different sizes. And you have, the general purpose zones, and then you also have the special zones for certain types of objects. For example, like commonly used objects, like file objects or whatever, will typically go in their own zone. And that's partly for security, but partly for performance as well. Now, in iOS 14, Apple introduced something called zone sequestering. And the idea there was to prevent special zones from being able to occupy the same virtual address space as generic data allocations. So basically, just trying to prevent cross zone attacks, which makes sense because before it would be possible to do some kind of heap manipulation to get a zone's backing memory released and get used for something else. So if you fill up a page with objects, you free them all. Apply some memory pressure to get that page garbage collected. It could be used for a different type of zone that you have more control over and be able to exploit some bug. So the idea of the zone sequestering was to make it so that the virtual address space for that zone couldn't be reused. iOS 15 took it a step further and introduced chaotic type, which basically further isolates the general purpose allocations into zones for different types. Go ahead,
Jump
Lucy. You
in,
sounded like you
yeah.
want to say something.
Yeah, I want to kind of comment on the sequestering. I thought it was interesting how they approach that. So they do mention how they're approaching this whole thing as they want to go through and have zero CPU and zero actual memory hit for this because obviously Apple stuff, they have to scale from fairly low power devices like your Apple Watch all the way up to they say the high performance Mac machines. I think there can be some controversy over that claim, but they talk about trying to go for that performance. So the way they actually went about implementing this, I thought was at least interesting. Basically, they still hold on to the virtual address. So whenever the zone gets allocated, it'll hold on to the virtual mapping that it gives it. That address will still be held, and it'll just free up the backing chunk, and it adds on a little bit of extra memory usage as it needs to track that. In these as it tracks, basically it lists the non-populated pages. I did think it was interesting they were willing to make that slight give in terms of having basically the extra lists being tracked in order to hold on to those addresses, almost like they're not freeing any memory. I was very much thinking of the joke about can't have a use after free if you don't free the memory. As they're holding back onto all those virtual addresses. But given especially 64-bit processes, so many things are these days, you've got such a huge virtual address space that it's probably not going to be an issue for a while.
Yeah. So getting into a bit of the specifics of what chaotic type does, basically there's a few hundred zones that are allocated. I think Cordis Talk mentioned 200. And any type can go into one of these zones. And once a zone has a type attached to it, that zone's virtual address space is essentially sequestered off. So no other type of zone can reallocate there. Only zones of the same type can reuse that memory. So that will kill a lot of UAFs. Cordy in his talk basically says that this is the death of UAFs on XNU. I don't know if I fully agree. I mean, obviously Cordy's knowledge on XNU is far and away not mine is not comparable to his. But there might be some situations where it still might be feasible. Something I'm thinking of, and we have a topic later on actually that touches on this kind of scenario. But if you like overlap cred objects or similarly sensitive objects where they're still the same type, but just causing the confusion between the different initializations could give you some useful primitive. I think those would still be viable with chaotic type. But anything where you're trying to cause a major type confusion where you're able to get control of a pointer or something like that, those kinds of exploits are probably going to die, um,
Yeah,
and or at least become a lot less reliable to hit.
yeah, it feels like there's a couple places that at least right now maybe still remain. One being, so as they're doing the KLOC type, the compiler basically decides it gives everything a signature, and then it'll zone them on those signatures. And with that signature, what they do is they effectively define like this object has like a pointer and then data and then whatever else. And it creates, I think they've, yeah, right here, like padding, pointer, data, um, dual, or pack. So pointer also protected by pack. It tracks them all like that and turns that into the signature based off of what's actually in that to limit how you can actually overlay things. But as they do call out, there are cases where applications will, or not applications, part of the kernel, will put pointers, say, instead of a uint type, which looks just like a data or like just a standard integer. Um, that's where they introduce an extra annotation you can add in there to actually indicate, like, no, this is a pointer, even though we're calling it an integer. But it does feel like that's a place where things can maybe get misclassified. Either because a developer forgot to annotate or because the annotation ends up being wrong at some point. They say it's something and it does get used as like pointer, whatever. It's kind of room in there, feels like, for at least like the human error to come back into it. And that's something they call, that's going to be insanely limiting. So I still feel like, saying the death of completely makes sense when it's like there might be some edge cases, but like your generic case, it generally seems to do a good job. And they talk a little bit more in the post about how the signature check, how they'll collapse some of the signatures. They use the example here of, this 122.111 signature, or sorry, 122.1.1 as a signature could be collapsed with some that also has like an extra two. I forget what the number stood for, but adds like that extra field pointing on it. They'll collapse those into the same thing. Maybe there's some that could be done in those areas also. That would need a bit more exploration, but like they are seem to explicitly think about that case where, in theory, nothing should be able to access that second one as another type. But given the complexity of applications, I could see some mistakes at least arising in that sort of area.
Yeah, even so, it'll dramatically shift like the attacker meta, which was their goal.
Yeah.
There was also a bit of another weakness with the iOS 15 implementation with variable sized allocations. They talked about that towards the middle of the post. One of the things they do there is they now only allow variable sized allocations where all elements are of a single type, or if there's a fixed size header with an array of elements of a single type. They've also isolated arrays of pointers into their own type of zone, relying on like the annotations and stuff. So yeah, I mean, pretty strong. It's gotten even stronger in iOS 16. And I mentioned QWERTY's presentation a few times. I guess I should say the name, which Balika reminded me of in chat. It's called Life and Death of an iOS Attacker, if you want to check that out. But yeah, like as QWERTY said in this presentation, and as Apple points out towards the end of their post, this is going to be a big hit to reliability. QWERTY's presentation mentions some other work Apple has done on that front too, which I think this blog post might touch on briefly, but it's not the focus of it. But on top of chaotic type, they also employ heavy randomization on the submaps that are used for the zones now when it comes to virtual addresses. So even if you can get like, if you're trying to do like a cross zone attack, it's really hard to get two zones that are useful to you adjacent to each other. You basically have a 1 in 8 chance of getting that to work. So it's still possible, but in the case of an attacker, like outside of jailbreaking or whatever, it's not really ideal, because when you have reliability at 1 in 8, that's pretty garbage. So yeah, I mean it's hitting iOS attackers hard. kind of like Word said, and like Balika mentioned in chat, it seems like Apple is targeting the iOS attackers more than like jailbreakers, because a lot of this stuff it will impact jailbreaking for sure. But on the reliability aspect, it doesn't matter as much anymore. When you get to jailbreaking, like there's been some jailbreaks in the past where you've had to panic like 100 times to exploit it, and people are fine with it generally. It's an annoyance at best. Whereas when you're talking about productization and stuff, it's a very different story. Um, Apple's also introduced a new mode, which I thought was really interesting. I think they call it like a lockdown mode. So basically, they have this lockdown mode in place where they can employ some more mitigations and attack surface reduction, and they disable things like JIT. So people who aren't going to be targeted can keep that stuff, keep lockdown mode disabled, so that they can get the better performance and whatever. Or people who want to jailbreak, obviously, you wouldn't enable lockdown mode. But if you're a more like sensitive target, if you're a high priority target, you can enable lockdown mode, and it makes it even harder for an attacker to be able to get a foothold and be able to do stuff. So yeah, Apple's been doing a lot, and it's interesting they've started the security blog too. It seems like they're taking a bit of a change in how they've been taking their direction when it comes to security. In the past, they've always been kind of at the cutting edge of the mitigation game. But it seems like they're going even harder now on like the attack surface reduction and trying to make security at least a little bit more open with this blog post.
It would
So
be nice if they opened up on the
indeed,
security front. I mean, they've always been very, I mean, as a company, they've always been very secretive. Even working there, as I understand it, like cross team communication is rough at times. Like secrets kind of just within the company too. So, I mean, it's not very nice for researchers to come in and try and do research on it. Opening that up would improve, I think, would help their security, even though they have done a reasonable job at it. Would be nice
yeah,
though,
for
yeah,
sure.
to get more information off them. Posts like this are great.
Yeah, it's a really awesome post, going through the technical details and laying it out in a way that people can start to speculate and see if there's ways around this. Um, Unfortunately for attackers, it seems like they've thought of quite a bit. It doesn't really seem like there's any obvious weaknesses at first glance, but maybe something will come up later on. Somebody will find a bypass around it, or at least you know something that makes it a bit easier to deal with. But yeah, it's a strong mitigation. It's kind of funny because this idea of like the heap sequestering we've seen explored in like Linux, for example, but it is not nearly as punishing in Linux as it is here. It can actually be bypassed fairly easily in Linux, from what I've heard. But in like XNU, because it's got more of like the hardware backed security model, and in tandem with things like pack and stuff like that that's going on, um, it's becoming very. You have to carry the weight of a lot of things if you want to attack iOS at this point. Um, you've got to deal with a lot. So yeah, I mean, life as an iOS attacker does seem to be getting a lot more difficult. So yeah, and it'll continue to get difficult. So, actually, there was one thing in chat I wanted to mention as well. Somebody asked it a bit ago. Yeah, Obfly asked, "I wonder if there are ways to exploit a privileged userland process from a kernel exploit." It has been done before. It's mainly been done on mobile, from what I've seen. But yes, there. So I think both in Apple and Android case, um, in both cases, the IPC is going to be handled through the kernel, obviously, to do inter-process communication between services and stuff. There have been vulnerabilities or exploits that have used subtle logic bugs in the IPC to be able to get access to like code or services that they shouldn't have been able to access, like permission bypasses and stuff. They have happened. They're not as like talked about or as popular, I guess, as
Yeah,
the more flashy memory corruption type issues, but they are out there. That they have been done.
yeah, I'm not sure I'd say it's necessarily that they're well, that they're less talked about, just that they're simply less common. Like we've covered a couple that have kind of taken at least similar routes to that. I think the one that comes to my mind actually is still attacking the kernel, but device driver response back. So not quite the same thing, but I think it's more just going that route has some extra layers of complexity. So, like, the current meta really isn't pushing exploits to do that just yet. I
It's
imagine in
not
the
the
future.
yeah. Sorry, I was just going to say it's not the path of least resistance.
Yeah, I think we
At the
covered a
moment,
paper actually that was talking about doing that. Or doing something like that a while back.
we might have. Yeah. It rings a bit of a bell, but I don't remember what that paper would have been. Um, but yeah, I mean, those are the kinds of attacks that the meta will have to shift to as more of these mitigations come into play when it comes to hitting memory corruption and things like overlapping in the heap. Because yeah, like type confusion is really powerful. It's how the basis of a lot of primitives in exploitation, and Apple's coming at it. So yeah, good post overall. Really strong start for their security blog. Hopefully we see some more stuff come out of it. Hopefully it's not just one post and then nothing for months or
One
years or
post a
something.
year.
Yeah, hopefully we see more. But as it is, yeah, that's a pretty good post. And if you want some of the other background information that's presented in a more digestible way, because this post is pretty dense. There is a lot to get through. Cordy's talk augments this post really well. So yeah, I'll give that another shout. And with that out of the way, I guess we'll move into another kernel kind of topic, which is a NetBSD vulnerability. Um, this one is a refcount issue in the Coredump functionality. Bug was introduced all the way back in NetBSD 5.0, so back in 2009. Pretty straightforward bug, albeit somewhat hidden by the fact that it was a refcount leak, so it would take a good amount of effort to trigger. Basically, the Coredump function in the kernel would take a reference on the process credentials to ensure it didn't get destroyed while it was using them. But in the case of the error path, it would never actually release the reference. And furthermore, it's pretty easy to trigger a fail path in this function through the vn open call, which is used for opening the backing vnode to of where to write the core dump to. If you just simply provide a path where your process doesn't have permission to write to, it'll follow that error path and leak the ref count. There's no ref count wrappers being used here. It is just like an atomic int. And the ref count is a 32-bit field, so it's not unfeasible to exploit. You can get it wrapped around in a somewhat reasonable amount of time where it's 32-bit and there's no checks on wrapping around. Exploitation is a little bit interesting because kind of tying back into the last topic, the chaos cred t objects are allocated in their own zone, which is the object you get a UAF on. They're not in the general purpose zone. But since we're talking about credential objects, you don't really need full control over the data. You just need to get a more privileged credential than yours to overlap with, and you can privilege escalate that way. And this is technically better because it leaves a lot less room for like crashes or other corruption. So your reliability with this kind of technique is a lot better too. So yeah, it's a memory corruption bug, but it's fairly easy to exploit. It's not really affected by like mitigations or anything because you're overlapping with the same type. Just different permissions attached to it. And yeah, towards the end they actually give the POC as a one-liner, so it's always fun to see. But yeah, I mean, not a super complicated bug. It is NetBSD, so I guess that can kind of be assumed going into it. It's not exactly the top of the list for secure operating systems or high mitigation operating systems, but uh, yeah, I mean, these ref count leak type issues are pretty fun. Unfortunately, a lot of the time they're not exploitable. So the cases where they are exploitable, like this one, uh, it's cool to see. It's nice to be able to cover those types of issues from time to time. So, and yeah, the blog post is also pretty accessible. So even if you're not super familiar with BSD or kernel exploitation, uh, it breaks it down pretty well and keeps it nice and succinct. So yeah. XCD80 mentioned it doesn't affect OSX. Um, OSX, so there is like an interesting history between OSS or XNU and BSD. There is like shared code. Coredump is probably not one of them. For the most part, at this point, I'm pretty sure XNU and OSX only really have the BSD networking stack. Pretty much everything else will be their own code. So yeah, it doesn't surprise me at all that this wouldn't really affect like XNU or whatever. Um, Especially when it comes to something like Coredump, because that's the kind of thing that Apple would customize. So yeah. Um, but yeah, not too much to say on that one. Just kind of a fun issue, and yeah, we'll get into our next topic, which is a Project Zero report of a Chrome UAF in AccountSelectionBubbleView class. This is specifically in create account row when fetching an image. Um, it gets a little deep into the code here, but the problem essentially boils down to this create account row function we'll call bind once, and bind an image view to this OnAccountImageFetched callback. Problem is that image view might have been destroyed before the callback can complete. Thus, a UAF is possible. So it's sort of similar to the edge vulns we saw last week, where they kind of have this lifetime based issue when it comes to things that are happening in the UI. So this vuln is in the sign-on dialog for account selection. And again, like the edge vulns, it's kind of an odd feature. It's probably not one that's going to be useful for attackers. But it is still a fairly trivial UAF due to not managing the image view lifetime properly. It is a vulnerability, but again, kind of falls in that class of self-attack almost. It's going to be really hard to get a victim to go through the process of triggering this bug on themselves. So
Yeah, that's kind of the questionable part is, exploiting this. We kind of have that same discussion as last week, maybe in like a kiosk situation, but otherwise it feels like you're probably not really exploiting this one like for a good purpose. It's more just a bug.
yeah. And again, one of those areas that's probably not being looked at as much, which is why a more trivial lifetime issue like this exists there. So, yeah,
Yeah,
something to be aware
although
of.
it is also the kind of thing, just callbacks are kind of hard to get right. 'Cause as soon as you start concurrency makes things kind of difficult to wrap your head around at times. In this case, just the fact that passes in that raw pointer into the callback then means if something happens between the callback actually being executed and the pointer being used, you have an issue. Um, yeah, it's just it feels like a very classic sort of issue to be having, and yet, um, I guess just interesting on the exploitation side. Yeah, I guess we don't really want to go back into that discussion about how you'd exploit this or those scenarios, but I am curious though, since it did get a CVE, what they actually rated it.
Oh, I didn't notice it was assigned to CVE. Oh, yeah, actually,
Yeah,
okay, yeah, it is there
so
in the side. Um, yeah, I'd be curious on that.
yeah,
The other
I'm
thing I
just
thought I'd mention is it is a little surprising the way this bug exists with just getting the raw image view pointer. I say that because like C++ and like just the browsers in general tend to have these more like smart automatic tracking type of objects that take advantage of like smart pointers and things like that so that these kinds of issues are harder to have. um, it is a little interesting that they're just getting like a raw pointer there to the image view. That's a bit of a code smell in and of itself, I guess, but uh, yeah, that jumped out at me a little bit as we were covering it, but
yeah, using the raw
yeah.
pointer there did jump out also. I just didn't want to necessarily make a claim on how you'd avoid that in terms of using the smart objects or smart
Yeah,
pointers.
fair enough.
I pulled up the CV here and actually got an 8.8. And we've got access vector
Okay.
network control low, privilege require none. UI or user interactions are, which I don't recall exactly what that stands for. But that's not none. Scope, and then yeah, CIA is all high because assuming you exploit it, you do kind of compromise everything, so that's fine. Um, Access vector network feels like that one, like, is it network or is it more low? Because like, what's the network access on it? Maybe this code is reachable beyond where we think. I'm thinking, just going off of the original report here, account selection bubble view. I'm thinking it's that thing you click on the top right and you can like choose a Chrome account.
It is because they
Um,
mention in the reproduction steps that you would have to
oh
use the
yeah,
click me when they create the account dialog rows. So Yeah, I think maybe this is just one of those cases where CVE or the CVSS score doesn't really do a good job of conveying the
Well,
impact of it.
but then at the same time, looking at reproduction, he has a repro.html,
I
which
looked
needs
at
to
that
be
file.
served. Which so is there some way that they're being able to see at least that event happens?
Basically, what that HTML file did, if I remember correctly, is it just basically sends a request to get the dialog opened up. It's not anything like super special. It's like 5 lines of code or something. It's not doing anything crazy.
Does
So
it have to? Well, so it prompts a dialogue though. So if you immediately close the dialogue, you're going to have a good chance of getting that UAF. So maybe this is more exploitable than I was thinking. Actually, I wasn't really thinking that you'd be able to trigger that from just from a website to actually pull this prompt off. But that does make it sound like there might be a bit more of a complex, or sorry, a bit more of a practical route, I guess.
yeah, perhaps. I just opened up the file to refresh my memory. They use the navigator credentials get routine and do like an identity request to this fedcm.json file they have set up. So yeah, it's basically just invoking the request to open the dialog, as far as I know. But yeah, I mean, like I said, kind of interesting issue. Questionable exploitability. Maybe it is a little bit more useful than the edge ones, but still, it's going to be noisy if nothing else. So
Yeah, I mean the thing is, if that is reachable, then that does seem like a reasonable bug there, and I'm kind of hitting on it for not being exploitable. But oh no, seems like we might just be missing something, I guess.
yeah. All right, so we'll get into our last blog post here, which is a vulnerability disclosed by Trail of Bits called Stranger Strings. I like the title in this one, pretty good one. And Z, I'll let you get into this one.
Yeah, and this one really caught my eye because it's exploitable in SQLite. If you're familiar with SQLite, one, it's used all over the place, used everywhere. And two, they have a pretty decent security process. I mean, they've been on like fuzzing and all of that for a long time. They've always seemed to have a good process. They even call out in one of their pages, like they have an FAQ about vulnerabilities in SQLite and how, like, yes, some bugs have existed, but all the past bugs have really not been exploitable, like have required a user be able to provide their own database or have full control over a query or something, things that don't happen in practice, but are technically, might happen. This one, again, you do have some constraints over how things get passed in, but definitely seems a lot more exploitable. It basically comes down to an integer overflow. Effectively, what you've got is, first of all, SQLite has its own printf implementation, and this happens specifically with the Q, both capital lowercase and lowercase w format specifiers. If you're not familiar with those, that's okay because these are completely unique to SQLite, where Q and Q are basically just whatever you give in, it will escape quotes. Capital Q will wrap the value in single quotes, and lowercase q is just escaping. So putting a single quote in front of every quote, and the W is for double double quotes. So what you're left with is, or the vulnerable code, I guess I'll get into that, is basically tries to calculate a buffer size for the final string. So after it's gone through and applied, like added an extra escape character for all of the things it's escaping, it'll check, or it'll basically be adding up, add the sizes, and it'll see, is this large enough for it to fit inside of a 70 byte stack buffer? If the value is smaller than that buffer, it'll use a stack buffer. And that, as you'd guess, or as I've indicated also, um, that addition can overflow. So you end up with a 32 by 32 bit value, not byte, 32 bits there. If you provided a long enough string, when it's adding the original length plus the new characters that needs to add, that overflows, you end up with a very small, or actually you end up with a negative number, sorry, because it's signed. So you end up with the negative number, which of course is smaller than 70, so it uses the stack buffer and then iterates through, overflowing the stack buffer onto whatever else is on the stack, such as saved return pointer or a canary, whatever, basically overflowing right into it. So fairly straightforward in that sense, in that basically large buffer overflows, and as long as the overflowed value is under that 70, it'll work, or it'll overflow that buffer. Otherwise, it goes to allocate it, and it'll treat 32-bit value as a as size t, which then isn't exploitable. There was one interesting thing that they call out on this, which was divergent representation. So this is going to be a future post from them. As far as I know, it's not out just yet. But they ran into the case and looking at how they're actually going to exploit this, where the index that was being used in this buffer in this first part, where it's using the index, it's basically going to take the 32-bit EDX register and sign extend it out to get the index. So it'll actually go negative, and they have assigned index that can be used. And then in second case, so in the same function here, got one up there, same function later on, it goes and uses just the 64-bit value, so it's not going to do that sign extension. And he'll basically just use the positive value, kind of creating like the same access, the same variable, being represented here as both signed and unsigned, effectively, or having a negative and positive version being used in the same place, which just feels like a bit of a unique thing to see. And so they call this out as just divergent representations of the same thing. Adds a little bit of spice to the exploitation, I guess, but that's something they're going to be talking about in another post. But I did just want to shout it out there. As for the actual vulnerability here, there are questions about where and when it's going to be exploitable. Effectively, if you're compiling with canaries, they haven't proven exploitability in that case. If there are no canaries, then of course you get your stack overflow, and you've got that stack-based overwrite. So you've got a control flow hijack from there. There is at least a case where it can be exploited. But they're not sure about the case where you do have a canary. Of course, your overflow. A lot of compilers these days will set up a buffer like that so that you're not going to overflow into like smaller metadata. I'm not sure what other piece of data will exist on the stack, but it'll reorder the stack for that case. So you only really overflow into like the base pointer, canary, and return address. So you're going to have to deal with the canary in a lot of cases. Maybe there's something on there. I don't know what the stack structure is that you can look at trying to exploit, or perhaps some other pointers later on the stack, and you can get control before the canary gets checked. There are some things you can go there. It sounds like it might be a challenging exploit in that case. They weren't able to come up with a good way of exploiting it. Also, I should have mentioned this at the start of talking about this, but they were actually inspired to look at this vulnerability after another post that they read, which was from
I think it was from early
PHP
this year.
filter vars. Yeah, well, it's something we covered back on episode 131. So they were inspired by that, which was a PHP issue where they had the signed, I believe it was a unsigned value. Yeah, unsigned gets converted to a signed value. They were looking for those issues, and they found kind of something that looked like it would be vulnerable here in SQLite. Tried it, turned out they got a crash, not just out of bounds access they were expecting from it because of the basically went down a different route. So I explained the vuln here, but do want to shout that out because I thought it was a neat and fun little exploit back on 131. That was PHP filter var shenanigans for the topic there. But yeah, I mean, on a whole, it's cool to see something in SQLite because so often the bugs are pretty impractical. This just requires a large input being used like a string anywhere in there, so can be accessible as long as it hits that the printf, which is used internally in terms of crafting some of the queries. So seems pretty reachable. Yeah, nice to see. I'm surprised it hasn't been found before, because this has apparently existed since 2000. Yeah, released October 17th, 2000. and then just patched in July of 2022. So 22 years old. Definitely a interesting bug. It is. I could understand why maybe it wasn't detected super early on, being that does depend on that 64-32-bit differential. Um, so if you're on like a 32-bit system, as was more common in 2000, if not 16-bit, um, it might have been missed there, but like they've been doing the fuzzing for a long time. So this seems like one of those cases where perhaps the fuzzing just wasn't doing very large strings like this. Um, and just it never happened to reach this case, but yeah, a little
So
bit
this is
surprising.
something.
Oh, go ahead.
This is something I wanted to talk about actually because they go into this towards the end of the blog post. Because as you said, like SQLite is very heavily fuzzed. It is like integrated as part of their process. So they were kind of wondering too, like, okay, it's well tested. Why did this bug get through? Part of it, I think, is because it has to have really large strings. It's not really an ideal kind of test case for a fuzzer. But the other thing they call out is the fact that this overflow ultimately happens in a loop, right? The iterator can keep going and go out of bounds. And they talk about how it's a bit harder for the fuzzer to see that as like an important like code block. Basically calling out that like branch coverage instrumentation is not really good enough for this kind of scenario. Like you could be covering that loop in your fuzzer, but it's only after it's executed tons of times that an exploitable condition opens up. So this sort of highlights an area where fuzzers are a bit weaker when it comes to these kinds of loops.
At least
And these
coverage
cases where you need
guidance.
really large strings. Yeah, coverage guidance, I guess, is a better
Yeah,
way
and
of
we used to
saying
talk
that.
about that more on the podcast, where it's like coverage guidance is really good. Like it's been very effective. Um, but it's not great. We just don't really have a better option that's like convenient at this point. But yeah, I guess this kind of illustrates that aspect too.
Yeah. Something I thought I'd quickly talk about in the chat was Bleaka mentioned, is this another exploit to get you boot time jailbreak on PS4? Um, I don't know. I mean, I haven't looked at SQLite on PS4. I'm assuming it would be that stack canaries would be in play, so probably not really an ideal bug in that respect. Um, to be honest, like I don't want to go too off topic here, but to be honest, I've never really had that much of an incentive to try to get a boot time jailbreak on something like the console. To me, being able to reboot into a clean state is a feature. Like I like to be able to do that. So I've never really been, on board for that stuff. Maybe you could work this into like a boot time exploit chain, but I feel like stack canaries would make it so you would need another bug, and that would probably kill it as a vector. You'd probably be better off trying to look for something else. But I will state that it's not an area I've particularly looked at, so I could be wrong there, but I don't think it would be an ideal exploit for that. But yeah, I
Yeah, I
mean,
mean,
SQLite is used in a lot of places, so there are definitely some systems where this could be useful.
yeah, I think that really
That don't use stack
depends,
canaries.
as you call it out there. Is it being built with canaries or not? That seems to be kind of the big hurdle on this one. Of course, trying to exploit this alone could also be challenging because this is just a stack smash. You're getting that return address. What are you going to write over it? You need
Yeah, I
something
mean,
else to go with it.
you could do like a partial overwrite. So like
True. Yeah.
ASLR and stuff wouldn't be too big of a problem probably, but yeah, it would be a bit of a tricky exploit for sure, especially in like a PS4 or just any like boot chain type exploit. But because of like how useful SQLite is and how much it's used, there are potentially other products that would have it used in the boot chain that could be compromised that way too. That wouldn't be as secure. So
Yeah.
it's a good call out.
And yeah, a lot of things kind of end up building SQLite themselves or building from source. I'm not even sure if SQLite provides pre-built binaries of the library itself. I mean, they provide some pre-built binaries, but I think that's just for tooling. So because
Yeah.
of that, you really get a lot of influence from the build methods on how wherever they're getting it from, and it's not really standardized on like everybody's going to be building this with canaries or without.
Yeah. All right. So that's pretty much all the topics that we have. We do have one shout out, which I'll let Z get into, and then we'll wrap up the show.
I'll give this one shout out here. I'll be honest, is reading it from the point of view of trying to understand the vulnerability. I didn't like the post. It's long. It just goes into a ton of what I'd feel like were irrelevant details. But at the same time, it goes into a lot of the details over here's how they tried to find this point. Here's how they tried to find what called it, setting up their breakpoints or watch points for whatever. Um, it goes into a lot of that sort of detail, which could be interesting for somebody who is looking for more of a beginner look at some of this Windows stuff. So I want to at least shout it out here. It's fairly detailed, tons of screenshots here over exactly what they're doing and all of that. So you might get somewhere from it. Give it a glance if that interests you. But yeah, I also had a hard time just reading it for like a summary. So mixed note on that, but there's a lot of information here in terms of process that might be valuable to someone.
Yeah, and that's Windows RPC for those that are listening and can't see the screen.
Yeah.
So yeah, a bit of a long blog post, but it does go into some of the background, and that could be useful to some people. But it's also a little bit too specific for us to like cover as a full topic, especially considering how long it is. So yeah, we're just doing it as a shout out. It is there. Feel free to check it out if Windows stuff is interesting to you. All right. So with that out of the way, that's everything that we have for this week. Thank you, everyone who tuned in. You can catch the VOD on Twitch immediately or on other platforms like YouTube tomorrow. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. If you want to join our Discord and follow us on Twitter, links for those are down below or in the chat. And yeah, we'll be back next week. It's worth noting also that we have a daylight savings time change coming up next week, so we will be adjusting for that. For those of you that don't observe DST, will be an hour later for the winter. So, just keep that in mind. I hate DST. I hate that we have to deal with it, but we do. Maybe one day it'll go away. But yeah, it is something to take note of for if you're tuning in live to the podcast. And yeah, we'll see you next week.